All right, so to calculate the derivatives of other implicitly defined functions, we proceed as in examples 1 and 2. We treat y as a differentiable function of x and apply the usual rules to differentiate both sides of the defining equation. So in this example, we have a y on either side of our equation. So I'm going to show you how it is that we're going to solve this using implicit differentiation. So we're going to show that the slope of dy dx is defined at every point on the graph. 2y equals x squared plus sine of y. So just like before, and I'm going to show the way that they do it in the book first, and then second I'll show you guys the way that I was taught again. So since we are taking a derivative with respect to x, when I have that 2y, the derivative of 2y is just going to be 2, and that's going to be 2 times dy dx. So even though it's just simply a y, I'm going to make a little note up here, this is going to be like the composition of functions. So take the derivative so that we have 2y, and then it's the derivative of the inside. So that's why we get the 2 dy dx is equal to derivative of x squared is 2x plus cosine of y dy dx. Okay, so in order to deal with those dy dx's, we need them both on the same side since they have full dy dx's. Now I need to subtract cosine of y dy dx from both sides. And once they are both on the same side, what we are going to do is we're going to factor that dy dx out. Since both terms have a dy dx, we can factor it out, so that'll give us dy dx 2 minus cosine of y equals 2x. And then lastly, to solve for dy dx, we're just going to divide by 2 minus cosine of y on both sides. Okay, so dy dx is equal to 2x over 2 minus cosine of y. Okay, then for the formula for dy dx is defined at every point x and y except for those points at which cosine of y is equal to 2. Since cosine of y can never be greater than 1, this will never happen. So that's our solution right here. And then again, quickly, I'll just show you just the second way. And again, this might take longer. You might not like the way that I was taught it. That is totally fine. You can stop the video right here. But we, again, have 2y is equal to x squared plus sine of y. So I would say 2 dy, because we took the derivative of y, and then 2x dx minus sine of y dy. So then I would say, whoops, I messed that little part up. So cosine of y dy. I would move all the dy's to one side. So then I would end up with 2 dy plus cosine of y dy equals 2x dx. Factor out the dy's. So 2 plus cosine of y equals 2x dx. And then from here I would divide by dx and divide by 2 plus cosine y. So we get the same thing as we got before. Dy dx equals 2x over 2 plus cosine of y.